discuss regression algorithms and we discuss classification algorithms. Now it's time to talk about unsupervised learning algorithms. Under unsupervised learning algorithms, we try to solve clustering problems. And the most important clustering algorithm there is known as k-means clustering. So we're going to discuss the k-means algorithm. I'll also show you a demo where we'll be executing the clustering algorithm and seeing how it is implemented to solve a problem. Now, the main aim of the k-means algorithm is to group similar elements or data points into a cluster. So it is basically the process by which objects are classified into a predefined number of groups so that they are much dissimilar as possible from one group to another group, but as much similar as possible within each group. Now, what I mean is, let's say you're trying to cluster this population into 4 different groups such that each group has people within a specified range of age. Let's say group 1 is of people between the age 18 and 22. Similarly, group 2 is between 23 and 35. Group 3 is 36 and 39 or something like that. So let's say you're trying to cluster people into different groups based on their age. So for such problems, you can make use of the k-means clustering algorithm. One of the major applications of the clustering algorithm is seen in targeted marketing. I don't know how many of you are aware of targeted marketing. Targeted marketing is all about marketing a specific product to a specific audience. Let's say you're trying to sell fancy clothes or a fancy set of bags and all of that. Now, the perfect audience for such product would be teenagers. It would be people around the age of 16 to 21 or 18. So that is what targeted marketing is all about. Your product is marketed to a specific audience that might be interested in it. That is what targeted marketing is. So k-means clustering is used majorly in targeted marketing. A lot of e-commerce websites like Amazon, Flipkart, eBay, all of these make use of clustering algorithms in order to target the right audience. Now let's see how the k-means clustering works. Now the k in k-means denotes the number of clusters. Let's say I give you a data set containing 20 points and you want to cluster this data set into 4 clusters. That means your k will be equal to 4. So k basically stands for the number of clusters in your data set or the number of clusters you want to form. You start by defining the number k. Now for each of these clusters, you're going to choose a centroid. So for every cluster, there are 4 clusters in our data set. For each of these clusters, you'll randomly select one of the data points as a centroid. Now what you'll do is you'll start computing the distance from that centroid to every other point in that cluster. As you keep computing the centroid and the distance between the centroid and other data points in that cluster, your centroid keeps shifting because you're trying to get to the average of that cluster. Whenever you're trying to get to the average of the cluster, the centroid keeps shifting because the centroid keeps converging and it keeps shifting. Let's try to understand how k-means works. Let's say that a data set like this is given to us. Let's say we're given random points like these and you're asked to use k-means algorithm on this. So your first step will be to decide the number of clusters you want to create. So let's say I want to create 3 different clusters. So my k value will be equal to 3. The next step will be to provide centroids of all the clusters. What you'll do is initially you'll randomly pick 3 data points as your centroids for your 3 different clusters. So basically this red denotes the centroid for one cluster. Blue denotes a centroid for another cluster and this green dot denotes the centroid for another cluster. Now what happens is in k-means, the algorithm will calculate the Euclidean distance of the points from each centroid and assign the points to the closest cluster. Now since we had 3 centroids here, now what you're going to do is you're going to calculate the distance from each and every data point to all the centroids and you're going to check which data point is closest to which centroid. So let's say data point A is closest to the blue centroid. So you're going to assign the data point A to the blue cluster. So based on the distance between the centroid and the cluster, you're going to form 3 different clusters. Now again, you're going to calculate the centroid and you're going to form a new cluster which is formed better clusters because you're recomputing all the centroids. Basically, your centroids represent the mean of each of your cluster. So you need to make sure that your mean is actually the centroid of each cluster. So you'll keep recomputing these centroids until the position of your centroid does not change. That means that your centroid is actually the mean or the average of that particular cluster. So that's how k-means works. It's very simple. All you have to do is you have to start by defining the k value. After that, you'll have to randomly pick the number of k centroids. Then you're going to calculate the average distance of each of the data points from the centroids, and you're going to assign a data point to the centroid it is closest to. That's how k-means works. It's a very simple process. All you have to do is you have to keep iterating and you have to recompute the centroid value until the centroid value does not change, until you get a constant centroid value. Now, guys, again in k-means, you make use of distance measures like Euclidean. I already discussed what Euclidean is all about. So, to summarize how k-means works, you start by picking the number of clusters, then you pick a centroid. After that, you calculate the distance of the objects to the centroid. Then you group the data points into specific clusters based on their distance. You have to keep computing the centroid until each data point is assigned to the closest cluster. So that's how k-means works. Now let's look at the elbow method. The elbow method is basically used in order to find out the most optimum k value for a particular problem. So the elbow method is quite simple actually. You start off by computing the sum of squared errors for some values of k. Now, sum of squared error is basically the sum of the squared distance between each member of the cluster and its centroid. So you basically calculate the sum of squared errors for different values of k. For example, you can consider k value as 2, 4, 6, 8, 10, 12. Consider all these values, compute the sum of squared errors for each of these values. Now, if you plot your k value against your sum of squared errors, you will see that the error decreases as k gets larger. This is because the number of clusters increase. If the number of clusters increase, it means that the distortion gets smaller. The distortion keeps decreasing as the number of clusters increase. That's because the more clusters you have, the closer each centroid will be with its data points. So as you keep increasing the number of clusters, your distortion will also decrease. So the idea of the elbow method is to choose the k at which the distortion decreases abruptly. So if you look at this graph, at k equal to 4, the distortion is abruptly decreasing. So this is how you find the value of k. When your distortion drops abruptly, that's the most optimal k value you should be choosing for your problem statement. So let me repeat the idea behind the elbow method. You're just going to graph the number of clusters you have versus the squared sum of errors. This graph will basically give you the distortion. Now, the distortion is obviously going to decrease if you increase the number of clusters. And there is going to be one point in this graph wherein the distortion decreases very abruptly. Now, for that point, you need to find out the value of k, and that will be your most optimal k value. That's how you choose your k-means k value and your knn k value as well. So guys, this is how the elbow method is. It's very simple and it can be easily implemented. Now we're going to look at a small demo which involves k-means. This is actually a very interesting demo. Now guys, one interesting application of clustering is in color compression with images. For example, imagine you have an image with millions of colors in it. In most images, a large number of colors will be unused, and many of the pixels in the image will have similar or even identical colors. Now, having too many colors in your image makes it very hard for image processing and image analysis. So, this is one area where k-means is applied very often. It's applied in image segmentation, image analysis, image compression, and so on. So what we're going to do in this demo is we're going to use an image from the scikit-learn data set. Okay, it is a pre-built image and you will require to install the pillow package for this. We're going to use an image from the scikit-learn dataset module. So we'll begin by importing the libraries as usual, and we'll be loading our image as China. The image is china.jpg and we'll be loading this in a variable called China. So if you want to look at the shape of our image, you can run this command. So we're going to get a three-dimensional value. So we're getting 427, 640, 3. Now this is basically a three-dimensional array of size, height, width, and RGB. It contains red, blue, green contributions as integers from 0 to 255. So your pixel values range between 0 and 255. And I think 0 stands for your black and 255 represents white, if I'm not wrong. And basically, that's what this array shape denotes. Now, one way we can view this set of pixels is as a cloud of points in a three-dimensional color space. So what we'll do is we will reshape the data and rescale the colors so that they lie between 0 and 1. So the output of this will be a two-dimensional array now. So basically, we can visualize these pixels in this color space. Now what we're going to do is we're going to try and plot up pixels. We have a really huge data set which contains around 16 million possible colors. So this denotes a very, very large data set. So let me show you what it looks like. We have red against green and red against blue. These are our RGB values, and we can have around 16 million possible combination of colors. The data set is way too large for us to compute. So what we'll do is we will reduce these 16 million colors to just 16 colors. We can do that by using k-means clustering, because we can cluster similar colors into similar groups. So this is exactly where we'll be importing k-means. Now, one thing to note here is because we're dealing with a very large data set, we will use the mini batch k-means. This operates on subsets of the data to compute the results more quickly and more accurately, just like the k-means algorithm. Because I told you this data set is really huge, even though this is a single image, the number of pixel combinations can come up to 16 million, which is a lot. Now, each pixel is considered as a data point when you take an image into consideration. When you have data points and data values, that's different. When you're studying an image for image classification or image segmentation, each and every pixel is considered. So basically, you're building matrices of all of these pixel values. So having 16 million pixels is a very huge data set. So for that reason, we'll be using the mini batch k-means. It's very similar to k-means, only difference is that it'll operate on subsets of the data. Because the data set is too huge, it'll operate on subsets. So basically, we're making use of k-means in order to cluster these 16 million color combinations into just 16 colors. So basically, we're going to form 16 clusters in this data set. Now the result is a recoloring of the original pixel, where every pixel is assigned the color of its closest cluster center. Let's say that there are a couple of colors which are very close to green. So we're going to cluster all of these similar colors into one cluster. We'll keep doing this until we get 16 clusters. So obviously to do this, we'll be using the clustering method k-means. Let me show you what the output looks like. So basically, this was the original image from the scikit dataset, and this is the 16 color segmented image. Basically, we have only 16 colors here. Here we can have around 16 million colors. Here there are only 16 colors. If you count also, you can only see particular colors. Now, obviously, there's a lot of distortion over here, but this is how you study an image. Remove all the extra contrast that is there in an image. You try to reduce the pixels to a smaller set of data as possible. The more varied pixels you have, the harder it is going to be for you to study the image for analysis. Now, obviously, there are some details which are lost in this, but overall, the image is still recognizable. So here, basically, we've compressed this with a compression factor of around 1 million, because each cluster will have around 1 million data points in it, or pixel values in it, or pixels in it. Now, this is an interesting application of k-means. There are actually better ways you can compress information in image. So basically, I showed you this example because I want you to understand the power of k-means algorithm. You can cluster a data set that is this huge into just 16 colors. Initially, there were 16 million, and now you can cluster it to 16 colors. So guys, k-means plays a very huge role in computer vision, image processing, object detection, and so on. It's a very important algorithm when it comes to detecting objects. So in self-driving cars and all, you can make use of such